Good morning, everyone. This is an audio recording for the visually impaired student from the book Pradeep, Organic Chemistry, Volume 3 by Dr. S.N. Dhawan. Terpenoids. Introduction. The terpenoids form a group of compounds, the majority of which occur in plant kingdoms. Isolation of this substance from the various part of plants, even from the wood in some cases, by steam distillation or ether extraction gives what are known as essential oils. These are widely used in perfumery, food flavorings and medicine or as solvents. Among the typical essential oils are those obtained from cloves, roses, lavender, citronella, eucalyptus, peppermint, camphor, sandalwood, cedar, and turpentine. The chief constituents of essential oil, which are obtained from the sap and tissues of certain plant and trees, were originally called terpenes. However, these days the more general name terpenoids is used. The reason being that the suffix "ene" signifies and unsaturated hydrocarbons, and hence as such the name terpenes is inappropriate to include compound such as alcohol, aldehydes, ketone, etc. However, the term terpenes is now used only to represent hydrocarbon with molecular formula C10H16. Isoprene rule. The thermal decomposition of almost all terpenoids give isoprene 2-methyl-buta-1,3-diene C5H8 as one of the product. Terpenoids on heating give isoprene is at 2-methyl-buta-1,3-diene plus other product. They suggest that the skeleton structures of all naturally occurring terpenoids are made up of isoprene unit. This is called isoprene rule and was first pointed out by Wallach in 1887. Thus, divisibility into isoprene unit may be regarded as a necessary condition to be satisfied by the structure of any natural terpenoids. Thus, according to modern definition, terpenoids are hydrocarbons of plant origin having the general formula C5H8 whole N, where N is equal to 2, 3, 4, etc., as well as their oxygenated, hydrogenated and dehydrogenated derivative. In 1925, it was pointed out by Ingold that the isoprene unit in natural terpenoids were joined head to tail, the head being the branch end of the isoprene unit. This divisibility into isoprene unit and their head to tail union may be referred to as special isoprene rule. The carbon skeleton of open chain monoterpenoids and sesquiterpenoids showed head to tail union of isoprene unit as shown below. Here the structure is given. However, it may be pointed out here that although this rule has proved very useful, yet it can only be used as a guiding principle and not as a fixed rule. Several expectations to this rule are known. For example, in lavendulol and erimomorpholone in carotenoids, and isoprene units are joined tail to tail and the center. At the same time, there are some terpenoids whose carbon content is not a multiple of 5 and those whose carbon content is a multiple of 5 but cannot be divided into isoprene unit. Classification. We have studied above that most natural terpenoids hydrocarbon have the general formula C5H8 whole N, where N is equal to 2, 3, 4, etc. It is this value of N which is used for classification of terpenoids as shown below. Here, if the value of N is 2, the number of carbon atom is 10 and the molecular formula is C10H16, the classification is monoterpenoids. Examples are myrcene, xerenol, alpha-terpenoyl, alpha-pinene, camphor, etc. If the number of N is 3, number of carbon atom is 15 and the molecular formula is C15H24. The classification is sesquiterpenoids and the example is farnesol, zingiberine, alpha-cadenine, etc. If the value of N is 4 and the number of carbon atom is 20, then the molecular formula is C20H32. The classification is diterpenoids and the example is pythol, abitic acid, etc. If the value of N is 5, the number of carbon atom is 25 and the molecular formula is C25H40. The classification is sesterpenoids. Sesterpenoids and the example is solanazole. If the value of N is 6, the number of carbon atom is C30 and the molecular formula is C30H48. The classification is triterpenoids. Example is quercetin. If the value of N is 8, the number of carbon atom is C40 and the molecular formula is C40H64. The classification is tetraterpenoids या carotenoids. Example is beta carotene in carrots and lycopene, red pigment of tomatoes. If the value of N is N, the number of carbon atom is 5 times of N and the molecular formula is C5H8 whole N. The classification is polyterpenoids and the example is rubber. The sesterterpenoids have been discovered only recently. The first example of this class is called solanazole, an acyclic unsaturated alcohol which was discovered in 1956. In addition to the hydrocarbon in each class as given in the above table, oxygenated compound like alcohol, aldehyde, ketone, etc. are also known which occur in nature. Each class of terpenoids have been further divided into subclasses such as acyclic, monocyclic, bicyclic, tricyclic and tetracyclic terpenoids according as they have open chain structure of have 1, 2, 3 and 4 ring respectively. Some representative example of each class, their structure, sources and chemical characteristics, if any, are summarized below. First one is monoterpenoid. Acyclic example are myrcene, molecular formula is C10H16, occur in verbena and bay oils. Next is xerenol, trans or E. Molecular formula is C10H18O, occur in rose oil. Next one is nerol. This is occur in cis or Z form. Molecular formula is C10H18O, occurs in oil of neroli, bergamot, etc. Next one is linalool. Molecular formula is C10H18O, optically active. Form occur in rose oil and the plus form in orange oil. Xerenol or citral A. Trans or E form. Molecular formula is C10H16O, occurs in lemon grass oil. Neral or citral A. Cis or Z form. Molecular formula is C10H16O, occurs in lemon grass oil. Citronilol. Molecular formula is C10H18O, optically active, occur in oil of citronella. Lavandulol. Molecular formula is C10H8O, occur in French lavender oil, does not obey special isoprene rule. Next is classification on the basis of monocyclic. Example is alpha terpenoid. Molecular formula is C10H18O, optically active, occur in plus or minus form and plus minus form. Limonene. Molecular formula is C10H16O, optically active, plus form occur in lemon and orange oil and minus form occur in peppermint oil, whereas plus minus form occur in turpentine oil. Next one is menthol. Molecular formula is C10H20O. Optically active, only minus form occur naturally in peppermint oil. Another example is menthone. Molecular formula is C10H18O. Optically active minus form occur in peppermint oil. Another classification is bicyclic. Example is alpha-pinene. Molecular formula is C10H16. Optically active occur both in plus and minus form in all turpentine oil. Next one is camphor. Molecular formula is C10H16O. Occurs in camphor trees of Formosa and Japan. It is optically active and the plus and minus form occur naturally, whereas synthetic camphor is usually in the racemic form. It is used in medicine and as a plasticizer for nitrocellulose. Another example is phanchone, isomeric with camphor. Molecular formula is C10H16O and optically active occur in oil of phenol. Next one is sesquiterpenoids. The sesquiterpenoids are classified into 4 groups according to the number of rings present in the structure. If we use the isoprene rule, then when 3 isoprene units are linked head to tail to form an acyclic sesquiterpenoids hydrocarbon, the latter will contain 4 double bonds. Each isoprene unit contains 2 double bonds, but one disappears for each pair that is connected. When this open chain compound is converted into a monocyclic structure, another double bond is utilized in the process. So monocyclic sesquiterpenoids hydrocarbon contain 3 double bonds. In a similar way, it will be found that a bicyclic contains 2 double bonds and a tricyclic 1. Representative examples are farnesol, acyclic form, and molecular formula is C15H22H26O. Occurs in the oil of amberty seed. Zigiberine monocyclic. Molecular formula is C15H24. Occurs in the minus form in ginger oil. Another example is alpha-cadenine bicyclic. Molecular formula is C15H24. Occurs in the minus form in oil of cubates. Next one is diterpenoids. Representative examples are pythol. It was obtained by hydrolysis of chlorophyll and also form parts of molecule of vitamin E and K. It is an acyclic diterpenoids. It has 2 chiral center, 7 and 11. And the example of pythol, molecular formula is C20H40. Abitic acid, C20H30O2 is a tricyclic diterpenoids. Triterpenoids, squalene, C30H50 is an acyclic triterpenoids. It has been isolated from liver oil of sharks. Other sources are olive oil and several other vegetable oils. Tetraterpenoids are all called carotenoids. For example, beta carotene C40H56 present in carrots and lycopene C40H56 which form the red pigment of tomatoes. Alkaloids. Introduction. Originally, the name alkaloids, which means alkali-like, was given to all organic bases isolated from plants. This definition, being too broad, covers a wide variety of compounds. Therefore, this definition was changed. Koenigs in 1880 suggested that alkaloids should be defined as naturally occurring organic bases which contain a pyridine ring. This definition, however, include only a limited number of compounds, and so the definition was again modified little later by Ladenburg, who defines alkaloids are natural plants compound having basic character and containing at least one nitrogen atom in a heterocyclic ring. With the discovery of more alkaloid, two more characteristics were added to the above definition of alkaloid. These characteristics were complex molecular structure and significant physiological activity. Thus, alkaloids are now defined as complex, nitrogenous compound isolated from plant which are mostly optically active, levorotatory, and produce some specific physiological action when administered into the body. Extraction of alkaloids. Alkaloids are usually found in seeds, roots, leaves, or bark of the plant. They usually occur as salts of various plant acids such as acetic, oxalic, citric, malic, tartaric acid, etc. A common method of extraction involves the following steps. The food is dried, then finally powdered, and then extracted with boiling methanol. The solvent is distilled off and the residue treated with organic acid, whereupon bases are extracted as they are soluble salts. The free bases are then liberated by the addition of sodium carbonate and extracted with various solvents such as ether, chloroform, etc. The mixture of bases thus obtained are separated by various methods including chromatography. General properties. The alkaloids are usually colorless, crystalline, non-volatile solid which are insoluble in water but are soluble in ethanol, ether, chloroform, etc. Some alkaloids such as quinine and nicotine are however liquid and a few are colored. For example, berberine is yellow. Most of the alkaloids have a bitter taste and are optically active, levorotatory. Thus, they are usually tertiary nitrogen compound and contain one or two nitrogen atom usually in the tertiary state in a ring system. Most of the alkaloids also contain oxygen. The optically active alkaloids such as quinine, brucine, etc. are very useful for dissolving racemic acid. They form insoluble precipitate with solution of phosphotungstic acid, phosphomolybdic acid, picric acid, potassium mercury iodide, etc. Many of these precipitate have definite crystalline shape and hence are used in the identification of alkaloids. These reagents are also used for detecting alkaloids in paper and thin layer chromatography. Classification of alkaloids. The most satisfactory method to classify alkaloids is according to the nature of the nucleus present in the molecule. For example, beta phenylethylamine group, second is pyrrolidine group, third is pyridine and piperidine group, fourth is pyrrolidine pyridine group, fifth is quinoline group, sixth isoquinoline group, seventh phenanthrene group, and eighth indole group. There is no systematic nomenclature of alkaloids. Trivial names are used and these end in the "-ine", indicating a base and usually indicate the source. Some important examples. The name, uses and structure of only simple alkaloids are given below. First one is D-ephedrine. It is an example of beta-phenylethyl group of alkaloids and occur in genus Ephedra. It is one of the most important drugs in Ma Huang, a Chinese drug. Physiologically, its action is similar to that of adrenaline and it can be taken orally. It has also been used in the treatment of hay fever, bronchial asthma, etc. It also increases blood pressure. It is a much stronger stimulant than caffeine. The structure of D-ephedrine is C6H5, CHOH, CH, and a CH3 group is present on CH and attached with and the CH unit is attached with NHCH3. Adrenaline. Like D-ephedrine, adrenaline is also an example of beta-phenyl ethyl group of alkaloid. It is also regarded as a non-steroidal hormone. It is also called fight and flight hormone since it prepares animal and human for emergency in many ways by raising the pulse rate, blood pressure, etc. It is also used locally to stop hemorrhage. However, it is active only when given by injection. The structure of adrenaline is here given. Conine. It occurs in hemlock plant and was the first alkaloid to be synthesized. The oil of hemlock was drunk by Socrates, the great Athens philosopher, when he was condemned to death in 399 BC. Conine belongs to piperidine group of alkaloid. Fourth one is piperine. It occurs in black pepper. It belongs to piperidine group of alkaloid. The stereochemistry about the two double bonds in trans. The cis stereoisomers is also called capsaicin and is responsible for the sharp taste of black pepper. Fifth one is nicotine. It is the most important member of pyridine-pyrrolidine group of alkaloids and occur in tobacco plant leaf. Natural nicotine is levorotatory. Enough evidence is now available which shows that cigarette smoking increases the heartbeat and thus causes a constriction of blood vessels, resulting in an increase in blood pressure. It also promotes blood platelet coagulation, which is responsible for many coronary artery heart attacks. Sixth one is atropine. It is the most important alkaloids of tropane group and occur in the root of deadly nightshade Atropa belladonna. The structure of atropine is here given. Atropine dilates the pupil of eye. Therefore, it finds extensive use in the detection and treatment of ailment of the eyes. A single drop of solution containing 1 part of atropine is 40,000 parts of water insufficient to dilate the pupil of eye. Atropine has also been used to relieve the night sweats, which are a distracting features of tuberculosis, and to reduce the activity of salivary and gastric gland. Cocaine. It is an important member of coca group of alkaloid. It occurs in coca leaves and is used as a local anesthetic. Cocaine is a habit-forming drug and is therefore used with great care. Taken internally, it increases physical and mental power, but the after effect is deep depression. Continued use of cocaine causes hallucination and eventually make them insane. Eighth is quinine. It is the most important member of cinchona group of alkaloid. It is mainly used as a febrifuge and as an anti-malarial drug. Opium alkaloids. Many alkaloids have been isolated from opium and they are divided into two groups according to the nature of the structure. First one is isoquinoline group. Example is papaverine, londanosine, etc. Lodanosine, etc. Second is phenanthrene group. Example is morphine. Papaverine, it is one of the optically inactive alkaloid and it does not contain any chiral carbon atom. It is a painkiller but has weaker physiological action than morphine. However, it finds use as antispasmodic for the relaxation of cardiac muscles and in the remedy for cough. In small doses, it causes light sleep narcosis, while in larger does it cause tetanus and respiratory paralysis. Second is morphine. Opium contain alkaloid like morphine and codeine, which are very effective analgesics. Morphine diacetate, commonly known as heroin, is the most widely used analgesic. These are chiefly used for the relief of post-operative pain, cardiac pain, and pain of terminal cancer and in childbirth. The structure of morphine, codeine, and heroin are given here. However, these alkaloids are known to be habit forming. Therefore, to guard against addiction and misuse, these alkaloids are not sold without proper prescription. Last and 10 number is reserpine. It is an important example of indole group of alkaloid. It is isolated from the Indian plant Rauwolfia serpentina. It is a powerful tranquilizer. It is also known as serpazil. It slows down the pulse rate and lowers the blood pressure. Thank you.